the introduction parts. Before going for the optical switching networks, let me introduce about first optical communication. As you all know, everybody, that optical communication is a consists of only transmitter, receiver. Both of them are interlinked with optical fiber. Here I have seen just block diagram of a transmitter, receiver, and both of them are connected with optical fiber. Main thing we have to focus on light source and detector, which are connected with the fiber. The light source is nothing but we can take based on the applications, either it may be LED or laser, that is going to be transmit light, okay, which carries the informations. So to the fiber, then fiber, there are different types of fiber. Generally, optical fibers made up of plastic and glass medium. So you know that plastic optical fiber, which can be used for data transmission only for long short distance communications, and the glass optical fiber can be used for very long distance communications. Again, that whether it is a plastic optical fiber or glass optical fiber, further can be classified into different types, like based on the mode, single mode and multi-mode fiber. Single mode step index fiber and multi-mode step index and multi-mode grade index. So as a electronics and communication engineering, so we all know that which kind of optical fiber is more useful and it can be used for very long distance communication. Let me come to the point that single mode step index optical fiber can be used for very long distance communications. Even undersea cable system also, we are using a single mode step index optical fiber. And multi-mode step index and multi-mode grade index optical fiber available, but there is no single mode grade index optical fiber available commercially. The reason behind that, the manufacturing of single mode grade index optical fiber is very difficult. It's a manufacturing problem, so it is not available commercially. Whereas when you go for multi-mode step index fiber and multi-mode grade index fiber, so due to some intermodal dispersion and because of it is having more number of modes, which may lead to dispersion effect. So better we go for single mode step index fiber, because single mode grade index not available. But whereas in single mode step index fiber, only that transmission loss, the transmission loss is very less because of the fiber is made up of silica, that to glass medium. So in this information, let me go to the advantage of optical fiber. That I have mentioned here, few point: more potential bandwidth, immunity to interference and crosstalk, low transmission loss, signal security, and low cost and availability. So let me say that the more potential bandwidth, it is a channel bandwidth. The optical fiber is having enormous bandwidth, 10 to the power 12 to 10 to the power 15 hertz. So more than terahertz. That is the bandwidth of optical fiber. It can support for many informations. Like at a time, we can transmit simultaneously. We can transmit more bulk information to the destination from the source. And immunity to interference and crosstalk. There is no electromagnetic interference. Why? Because it is made up of dielectric medium. Okay. Then there is no electromagnetic interference. Even the optical fiber can be installed under the high power transmission line. So suppose if you install any copper cable under the high power transmission line, what happens? Due to that electromagnetic interference, the data, the message which is traveling through the medium will be affected. But whereas in optical fiber, there is no possibility to interfere. That's why I said that immunity to interference, and there is no crosstalk. And low transmission loss. Why? Because here the fiber medium, the fiber is made up of silica. It is a pure dielectric medium. Due to the total internal reflection, the signal is getting reflected back and forth, and it is traveling through optical fiber. Then come to that signal security. So no one can trap the signals. Even, for example, we can say that when the signals are traveling through copper cable, like a coaxial cable, be able to trap the signals and to the other. But here, when the signals are traveling through optical fiber, no one can trap the signals. It is having more secure, highly secure. Then low cost and availability. Of course, it is a silica material is available, and it is availability of raw materials. So by the way, we can say that it is a low cost. So these are all about few advantages. Having these advantages, we can go for the optical networks. Okay, but see here, I told you light source and optical fiber. Then one more thing, detector. So even though the optical fiber is having more bandwidth, the system should support like a light source and a detector. So for very long distance communications, I told you we can make use of single mode step index fiber. At the same time, light source also should be preferable. In even detector also should be preferable. The light source can be a laser for very long distance communication. The detector can be avalanche photodiode, like we simply say that APD. Suppose if you use it for short distance communications, we can go for with the LED and a pin photodiode in detector side, receiver side. So based on the requirement, based on the applications, we can choose whether it is a laser or LED or single mode fiber or multi-mode fiber, whether it is a pin photodiode or avalanche photodiode. Okay. Next, sir. Then coming to that, just now I told you about optical communication introduction. That was nothing but point-to-point communications. When we go for optical networks, the same point-to-point communications, we can increase the way of communications. Okay, at a time. Then okay, so more number of source and destinations can be interlinked, connected together in the help of network. So called it is a network. So here we can say that more number of mode connected together to form a network, which all the nodes are interlinked with the help of optical fiber. You know, the fiber is having more advantages, like what I told you, 4-5 points I have mentioned there. So keeping those advantages, we can go for interlink with all the nodes which are available and making a optical network. Here I have shown that transmit information among various nodes of a telecommunication network. So the network like local area network, wide area network, metropolitan, regional areas, all the way to national and international and transsonic distances in the form of optical communications. So what is happening here, when we go for optical network, I told you point to only we have seen in the previous slide optical communication point to point link. Now here more source, many source to many destinations. So in that way we can make it as a optical network. So when we go for optical network, simultaneously huge amount of data can be transmitted and parallelly we can receive at the destinations. Next, please. So in order to have the more number of data can be transmitted from the source and at the same time we can receive at the destinations, we need to go for multiplexing technologies. So the multiplexing technology is the gateway of optical networks. So let me see that the different, what do you mean by multiplexing? That multiplexing is nothing but which is used to increase the capacity of fiber optic communication system by adding different signals at a different time or different wavelength or different frequencies. If we say about different signals can be added simultaneously with a different time, so-called it's a time division multiplexing. Different signals can be added simultaneously at different wavelength, so-called it is a wavelength division multiplexing. Different signals can be added simultaneously at different frequencies, so-called it's a frequency division multiplexing. So the multiplexing technology can be divided into three parts. I have mentioned here TDM, FDM, and WDM. But TDM, FDM is also can use for optical networks or optical switching networks. At the same time, if we go for wavelength division multiplexing technology, we can try to utilize the optical channel bandwidth. So that is the reasons I'm going for wavelength division multiplexing here. So I told you already the wavelength division multiplexing definitions, many signals can be added at a different wavelength. So-called it is a wavelength division multiplexing. The diagram, the network wavelength division multiplexing architecture I have shown here. See that there is a max and Dmax. Both of them are connected with optical fiber. Then from the DMAX, we can get the corresponding channel, lambda, channel 1, channel 2, channel 3, channel 4, and 5. Here I have given only 5 channels. All the 5 channels are given with the 5 different wavelengths, like lambda 1, lambda 2, lambda 3, lambda 4, and lambda 5, which are all lambda 1 may be for different sources like telephone. Lambda 2 or channel 2 may be a fax. Lambda 3 may be a internet. Lambda 4 may be a TV. Lambda 5 may be some other video. So all the different sources are connected with with the help of multiplexer and sent through the single mode step index optical fiber, which is carrying the signal for long distance. At the destination end, we can have one demultiplexer, which is used to DMAX, separated all the channels into the corresponding wavelength lambda 1, lambda 2, lambda 3, lambda 4, and lambda 5. So you will get the output. But see that in between multiplexer and demultiplexer, I have shown here some optical amplifier. So that optical amplifier we require. Why? Because when we go for long distance communications, somewhere we need to have that boost up of our light energy, light signals. So where we can make use of optical fiber. That optical fiber, it can be electronic like amplifier, or nowadays all the things are connected with only in optical domain. If we go with the optical domain, so we need to have here erbium doped fiber amplifier. Instead of electronic amplifier, we can make use of here erbium EDFA. Simply we say that EDFA, erbium doped fiber amplifier. That I told you already, the fiber is made up of silica. If you dope with the erbium, it becomes act as an amplifier. So just you can take 1 meter length of optical erbium doped fiber amplifier, you connect it every 10 kilometer or every 100 kilometer or every 1000 kilometer. So wherever it depends on the application, based on the requirement, that erbium doped fiber amplifier will boost up the signal, then it will travel for another 100 kilometer. Then after 100 kilometer, again use one erbium doped fiber amplifier, then it will boost up the signal, then it will forward to another 100 kilometers. So likewise, we can increase the distances. So this is what call it as a wavelength division multiplexing as well as erbium doped fiber amplifier. Then there are different types of erbium doped fiber amplifier like coarse WDM, dense WDM, ultra dense wavelength division multiplexing. So here I have shown some picture CWDM, DWDM, coarse wavelength division multiplexing, dense wavelength division multiplexing. So what is happening here? WDM network, we can go for only 12 channels can be transmitted simultaneously. If you go for example, I'm mentioning here. If you go with coarse wavelength division multiplexing, we can go for 12 channels. Dense wavelength division multiplexing 28, ultra dense wavelength division multiplexing may be 100. So likewise, the frequency band can be minimized when we go for the advancement of WDM technology. See the first diagram, CWDM, the green color showing 1550 nanometer, but here DWDM in the green color itself, we have more number of band of channels. Okay, now coming into that, next wavelength routing network architectures. It's already there in the slide. Wavelength routing. Now, what I'm saying, when we go for the research or any small kind of project, we can first thing we can select the wavelength routing network architecture. So for that, we need to have either WDM or coarse wavelength division multiplexing or dense wavelength division multiplexing or ultra dense wavelength division multiplexing. For this, in this WDM technology, there is a software called OptiSystem software, OptiSystem. If we go with OptiSystem, we can able to design WDM technology or DWDM or coarse CWDM or ultra dense wavelength division multiplexing. Then we can come to know the better understanding of this wavelength routing network architecture. Okay, so what do you mean by wavelength routing network architecture? So see here, we have some different nodes like node 1, 2, 3, 4, 5. 5 nodes are interconnected with optical fiber and wavelength have been assigned. See from node 1 to node 2, only lambda 1. is routed. So whatever the information wanted to communicate from node 1 to node 2, the message can be transferred only with the lambda 1. Whereas from node 2 to node 3, see that node 2 to node 3, so the node can go through via 5, 4 and reaching 3. So lambda 1, lambda 2 and number 3. Then node 4 and 5 interconnected with the fiber with the help of lambda 2. So like that, the wavelength lambda has been assigned from node 1 to node 2 or node 2 to 3 or 4 to 5. So called it is a wavelength routing network architecture. See that in WDM technology, there are the MUX having n number of channels, lambda 1, lambda 2. So which wavelength we need to select. So whichever the wavelength is free. So there we can make it for data traveling, sending. So here we have algorithm. So wavelength routing algorithm. So with the help of wavelength routing algorithm, that algorithm which is used to identify which route is free now, which wavelength lambda is free. So with the help of identifying the wavelength lambda, the data can be transferred from source node to the destination node. That's what here we have shown here. Wavelength routing node and the square shape is a N station. If we go to the next one, routing and wavelength assignment, simply say that RWA. Routing includes selecting a suitable path and assignment of wavelength includes for connection available wavelength allocated in the optical connections. There are two constraints in the routing and wavelength assignment. One is wavelength continuity constraint and another one is distinct wavelength constraint. Then see that next one. Please, sir, next slide, sir. Let me tell you two types of wavelength routing wavelength assignment. There is a static routing wavelength assignment and dynamic routing wavelength assignment. So these are the algorithm which we have to be installed in the WDM technique. Okay, so what is a static and what is a dynamic? Static in the sense, I have given statement here in the network. If the traffic patterns are reasonably well known and variation take place in any traffic over a long time scale, the most effective technique for optical connection establishment between client subnetwork by formulating static RWA. So what is happening here? Once the route is established from source to destination, the data has to be traveled only with the lambda, whether it may the lambda 1 has been established or lambda 2, whatever that. Once that lambda is established, we have to transmit the data only with that established wavelength lambda. Whereas the dynamic, from node 1 to node 10, in between there are 6-7 nodes are there. So completely from node 1 to node 10, lambda 1 has been assigned for data transmissions. Okay. Suppose if there is any problem occurs in between node 1 and node 10, say for example node 8, some problem occur. So immediately the WDM technology, we have assigned already that routing wavelength assignment algorithm, which will identify where the problem is occur. Immediately it can reroute the data from source node to destination node. So called it is a dynamic routing wavelength assignment. And before that, it will check is there any contention occur in between the node, source node to destination node. If there is any contention or a traffic occur in between, immediately it will reroute. So identify the free wavelength and assign and data can be transmitted. Okay. The next, come to that. Optical cross connect. Simply say that OXC. See, it is a very beautiful concept here. An optical cross connect with the n port of input and n port of output are capable to handle wavelength W per port can be thought of W independent optical switches. See that input port 1 in the input side, output side there is output port 1 is nothing but optical fiber, and that optical fiber connected with the wavelength Dmax. In between wavelength Dmax there is optical switches. the number of optical switches based on the number of wavelength which is going to carry by optical fiber. See here, input port 1 and output port 1. Okay, input port 1, the blue color and the violet color, only there are 2 wavelengths available. So based on the 2 wavelength, optical switches also we need 2. Suppose if you send 3 wavelength in single fiber, we need to have 3 optical switch, so that lambda 1, lambda 2 can be availed in all the switches and simultaneously sent to the output port 1, 2, 3 respectively. Say for example, input port 1 coming in, the lambdas are traveling through fiber. It is reaching the first demultiplexer. From the first demultiplexer, lambda 1, lambda 2 going to 2 optical switches. Lambda 1 to first optical switch, lambda 2 to next second optical switch. See that the now first optical switch consists of all lambda 1, 3 lambda 1. Optical switch, second optical switch having only lambda 2. So again, the first optical switch and the second optical switch interconnected with the wavelength Dmax having lambda 1, lambda 2 again. So in the output port 1, we will get the corresponding input wavelength lambda 1 and lambda 2 simultaneously. This is what call it as a optical cross connect. So that optical cross connect, we can design as much wavelength lambda, as much optical switch we require. Now, coming into the next one, routing wavelength assignment with 2 wavelengths per fiber. That was just now I have told you. If it is a 2 switches, the number of switches is purely based on the number of wavelength which is carried by optical fiber. That's it. I also see lambda 1 and lambda 2. Next. And another one important factor, conversion of wavelength. This is also possible. Like, there is a conversion of wavelength. There is a node, lambda 1, lambda 2, lambda 3, which consists of optical fiber. Node which interconnected with optical fiber. That optical fiber input is lambda 1, lambda 2, lambda 3. The output is lambda 1, lambda 2. Whereas, see that is called no conversion taken place. That diagram D shown, no conversion taken place. When come to that fixed wavelength conversion, like lambda 1 as such, input lambda 1, output also lambda 1. Whereas lambda 2, we are sending message data into the lambda 2, but getting output from lambda 3. Whereas when you send the data to lambda 3, we get the output data from lambda 2. That is a fixed one. Lambda 2 to lambda 3, lambda 3 to lambda 2. It's a fixed one. That also can make it. Then come to that limited, wavelength. So limited conversion wavelength, lambda 1 data go to either lambda 1 or lambda 2. Lambda 2 data can convert it into either lambda 1 or lambda 3. And lambda 3 can convert it into lambda 1 or lambda 3. Lambda 2 input convert into lambda 2 or lambda 3. Yes, lambda 2 or lambda 3. So likewise, we can limit the wavelength conversions. Then see that the full conversion, okay, lambda 1 going to lambda 1 or lambda 2 or lambda 3. Lambda 2 data can go to either again all 3. Lambda 3 also going to. So this conversion of wavelength is also, there is algorithm. So what kind of why? Because suppose if we are sending a data to lambda 1, okay, continue from source node, then till destination node, there are so many nodes they have to cross. So if someone in between node busy with the same lambda 1, it has to divert to lambda 2. That is not possible in no conversion of wavelength. Okay, whereas if full conversion of wavelength, everything is possible. Wherever you want, we can switch over. So this is what the conversion of wavelength is coming into the optical networks for switching over the data wherever it is getting free, wherever it is getting traffic, or wherever it is getting contention, or wherever it is getting full traffic signals. So by the time the full conversion of wavelength, it will be more useful for the users. Next, we'll come to that optical switching networks. What we have seen now, optical communication, then optical networks, then we slowly enter into the, wavelength division multiplexing. There are three different types, coarse WDM, DWDM, ultra WDM. Now we go for the optical switching networks. The switching networks' major advantage is more flexible and reconfigurable optical networks. That's what I told you. I told you just before this conversion, full conversion. So we can reconfigure the networks lambda 1 to lambda 5 or lambda 1 to lambda 4. Wherever you want, we can switch over the data wherever it is more flexible. There we can make use of optical switching network. Because of that, the speed can also be increased. Because no need to wait if any traffic jam occur or if any failure in the node, immediately we can switch over by keeping algorithms. The algorithm which play a major role in. So the suitable algorithm we need to make it. So I will tell you some of the research paper I have taken already. I'll show you just within another 10 minutes. See that the second point, optical switching networks may be a single channel or multi-channel whose configuration can be dynamically changed in response to varying loads of traffic and network failure by controlling the state of their tunable and reconfigurable elements of network accordingly. And speed can also be increased. So switching networks is giving more advantage. Then come to that, today's technology, the increasing amount of traffic originating and end-to-end optical network, the optical switching network commonly used. The hierarchy of optical switching network, FTTB, fiber to the business, fiber to the home, and passive optical networks, local area network, wide area network, metropolitan area network, ATM, and EPON, and 10 GB Ethernet. 10 GB Ethernet. So these are all some kind of optical switching network where we can send more and more data simultaneously from source to the destinations. Now the network services, that connection-oriented services, connection-less services. Next thing. Please, sir, next slide, sir. Network services, we can go for connection-oriented or connectionless services. Connection-oriented services in the sense, once the path has been established from source node to destination node, which is comes under connection-oriented services. Connectionless services in between, if something happens, so we have to go for the alternate route. So there we can make use of Internet Protocol IP is the example for connectionless network. Next, please. See the types of optical switching network. So what is optical switching networks? Then we go for the different types. Depending on the demand of traffic in various clients, that optical switching network can be classified mainly three: optical circuit switching network, optical packet switching network, and optical burst switching network. The first one, optical switching network, what it says, see that the path has to be, the optical circuit switching, it works based on the principle of wavelength routing, which is based on dedicated wavelength being assigned for each path from source to the destinations. That's what, see from the left side I have given on source, and the right hand side there is a system. A person who is working with a system considers a source. There is a system monitor kept at the right side. So from source to destination, the path has been established. The data will be transferred from source to destination. Once it is established, we need to send the data. Till the data is reaching the destination from the source, the route has to be clear. Once after reaching the data, based on the acknowledgement, again we can send the data. So what happens? There will be some drawback when we go for optical circuit switching network. So that can be overcome when we go for optical packet switching networks. So optical packet switching network, it is more important. Even many of the people, they are doing research on optical circuit switching, optical packet switching network. So what is saying optical packet switching network? See that there is a OGB, optical guide band, in the left corner, and there is a after payload, there is again optical broadband, then header, then synchronous data, then OGB. So what is happening? This is a payload which is carrying the data in between optical broadband. So that optical broadband, which is giving some interval to identify the next frame. Then header carries the data informations. So where it has to be reached. So all the informations will be available in the packet, and it will be transmitted from source node to the destination node. Okay, so one thing we can say that the very much flexible utilization of network, very efficient network utilization in the packet switching network, and high control route available. But whereas in optical switching network, the packet header is being processed either optically or electronically. That also we can say optically or electronically. But nowadays, everything comes under optical domain. So there is no point of discussing about electronically. But the optical, the conversion, that taking place based on that optical broadband. And another thing, the data payload waits in a delay line, optical fiber delay line of the before being forwarded to the next node. Okay, so the optical packet format or structure shown here, it consists of packet train where in each individual packet consists of optical broadband, header and synchronous data. So the header information carry the detailed complete address, and by seeing the header information, it establish the route path, and the data is following and traveling from source to destinations. And coming into that next one, optical burst switching network. So it is one of the most important. There only we are highlighting our today's session, optical burst switching network. Various types of client data are aggregated at the ingress node and transmitted as a data bus that later will be disassembled at the egress node. So what I'm trying to say that ingress node and egress node. Ingress node is nothing but one of the mux. Okay, egress node is one of the output side demux. Okay, in between multiplexer and demultiplexer, there is a network. There are optical switching network. So the data, there is a edge node. Edge node is nothing but, here I have shown, there is a green color, that is a 0 point, that is a source, and reaching the number one destination node. See that OBS network, what is doing, there is a blue color, small packet, that is a header information, and after the header information, there is some gap, okay, and there is a red color data burst. So the data burst consists of more number of packet. The data burst consists of more number of packet. Whereas in packet switching consists of the packet, it consists of data. Okay, packet consists of data. Whereas in burst switching network, the burst data consists of more number of packets. So obviously, when we go for optical burst switching network, more number of informations can be carried out. Data can be carried out. So before the data being transmitted, the header information is sent to the destination. That header information is going to all the node and establishing the path for the data burst. In between, data burst and header information, there is a gap. That is the delta here I have mentioned. That is nothing but offset time. That offset time can be varied by doing research. In research we are doing by varying that offset time, we can try to increase the number of burst data rate. This is also one of the research parts. Here the offset time can be, but when we go for more sufficient offset time, the utilization of optical channel bandwidth can be minimized. If we go for minimizing that offset time, we can increase the utilization of optical channel bandwidth. So called it is a optical burst switching networks. Hello. Hello, sir, madam.
Sir, screen is not sharing, sir. Your screen
Yes,
is
yes,
not
sir. Yes, sir.
visible.
Madam.
Brinda ma'am? Brinda ma'am?
Hello, ma'am. PPT is not visible, ma'am. It seems.
Yes,
Just
sir.
a minute, sir. I'll call Brinda ma'am.
Hello.
Yes, sir. I'm calling Brinda ma'am.
Yeah, please, ma'am.
No, ma'am. Yes, got it. Some network issue. Yeah. Hello,
Ma'am,
ma'am.
the PPT,
Yes,
ma'am,
ma'am.
not visible now.
I will share it again.
Yes, sir.
Visible, sir?
Yes, madam. Now I am in 17th, ma'am. Slide number 17.
This one, sir?
Yes, ma'am, please. Yes, correct, ma'am. Thank you, ma'am. See that optical burst switching network, the previous slide I have shown some kind of architecture, OBS architecture. Next, the processing time and especially time, processing time. See here, A is a node, B is a source, A is a source node, B is a destination node. See that, you know, that even wireless communications, we are, no, we have studied already the same process even in the optical switching network also. See the first thing, the blue color, you know, this is a header informations, then there is offset time, then there is a burst data. So that I told you know that offset time can be varied. By varying the offset time is one of the parameter we can go for the increasing the channel utilizations. Okay, we'll go for the next one, ma'am. Please next, ma'am. Next slide. Ma'am, next slide, ma'am, please. Ma'am, go to next slide, please. See the signaling protocol in OBS. So actually, this I supposed to discuss in the earlier, but just I'm coming down. Signaling protocol in optical burst switching network. So this is a major important point that what protocol, signaling protocol we have to follow. There are 4 different types generally. Now we have so many things, but we need minimum level, tell and wait, and tell and go, and just enough time, and just in time. So what we are doing in optical burst switching networks, just enough time. Okay, the header information, header data, burst header data we send. After some time, you send once again the data burst. So no need to wait for anything. You first send the header information. After some time, you send burst data. So it comes under just enough time. Okay, so we can go for tell and wait, tell and go, and just enough time, just in time, because each one carrying a lot of advantage as well as drawback in terms of speed, in terms of delay, or in terms of data rate and bandwidth, all the thing taken to the considerations. So I have what I am focusing on in optical burst switching network, JET. Okay, then come to the next one. The purpose of OBS, we have some research challenges. Ma'am, please next slide, ma'am. Here, I have taken 3 challenges I have seen from journals. The first one is design adaptive burst assembly algorithm for reducing burst loss and delay in OBS network. So by the way of making the algorithm like adaptive burst assembly algorithm, ABAA, the first line shows ABAA. By making this kind of adaptive burst assembly algorithm, how we are going for utilize the channel bandwidth and how we are going to reduce the delay and loss in optical burst switching network. That is the first challenges. Then second, the contention measured based on the second bullet point I have mentioned. The second contention is measured, the traffic where the burst data is going to be get traffic. So there, the burst loss ratio and link utilization can be measured. These two things, I have taken some research idea. I'll give some idea. Faculty members or students who are all going for research or project, it will be very useful for you. Within another 5 to 10 minutes, I'll go through some research output. So the way how we are going to get the betterment. See, this is a network arrangement. What I told you to the egress node and there is an ingress node, there is an input and output. There are many data available like internet protocol, ATM, gigabits, second, then SONET, synchronous optical network, and there is a control packet and there is a burst data to OBS network. This is a burst assembly. Second one, burst disassembly. So the first diagram will be in the ingress node. The second diagram will be egress node. In between, there will be a optical switching networks, which we have seen already in the previous slide. Now, the network topology, I have taken some small example. See that node number 2, I think it is not clear, but see that the extreme left side, there is a blue color. That is our source node. Then the extreme right side, the top, in the side corner, there is a node. We can make it as a destination node. So we need to transmit the data, that is a burst data from source node to destination node. This is like, let us consider as a network topology. So what happened, this is a WDM. We can make it as a WDM or a DWDM or ultra dense wavelength division multiplexing. Any kind of WDM, you can make it over here. But here, I have considered only WDM technology, wavelength division multiplexing network. Okay, so please next, ma'am. In this burst switching network, the people have used fuzzy inference system. Okay, fuzzy input value, timer, length, and load. So you see that burst data, burst data rate. What is the time of burst data? What is the length of burst data? And what is the load? Load is nothing but size different. Say for example, if a length is more, it consists of more data. If length is less, it consists of less data. Based on the length, you can go for the load. If length is more, it contains more data. Okay, burst data and the time of the burst data. So all these, keeping all these three parameters, and when you go with a fuzzy inference system, we can identify, we can go for the prediction method. So what is a new timer? What is a new length? What is a new load? Okay, then for the first time, we may get one new time, new length, new load. Keeping the same new time, new length, new load can be predicted in the next time. What will be the new time to, new length to, new load to? By keeping new time to, new length to, new load to, what will be the next? So call it as a timer, new time 3, new length 3, new load 3. Some kind of, each and every time by keeping the reference, the previous one, they go for the predictions. Likewise, we can send that burst data. So what is a next node? Whether the next node having more traffic, or is there any loss occur, or is there any traffic, or is there any the wavelength is free? All the things can be predicted. Based on that, we can go for the sending the data burst. So the fuzzy logic system, I think many of you may be knowing what is the purpose of fuzzy logic system. So I have seen one of the research paper, they have given very clear idea. Just I wanted to share with all the faculty member and students. And this is the fuzzy inference system. We may get low, medium, high. Okay, for a timer, load, and length. So based on this timer, load, and length, go with the 3 parameter: low timer, medium timer, high timer. Like low load, medium load, high load, low length, low medium length, high length. So keeping all these parameter, we may have some designed fuzzy inference system. I have kept some idea here in the table. So keeping all the thing, we come for the next slide. We come to know clarity. See the adaptive burst assembly algorithm. Here I have taken ingress node, egress node. That is a source node, destination node. There is a core node. In between ingress node and egress node, there are so many core nodes are available. I have taken only the sample 2 node. Okay, ingress node and core node. So what is happening? You know that the core node, what is happening in the egress node? The core node will update all the data. So likewise, what core node send the data, what is the speed, what is a traffic, what is a wavelength, all the data will be updated in the routing table. That will be given as a feedback to the next adjacent ingress node. So what happened? Based on the feedback, that ingress node will get the information from the source node, then it will transmit it. So likewise, each and every core node will having the adjacent node feedback system. By the way, the ingress node come to know what is the traffic jam or what is the data rate of the next node. So likewise, each and every core node will check with the adjacent node and keep update the information. Likewise, the data, burst data being transmitted from ingress node to egress node. Okay, by the way, we'll go for the next contention resolution technique. So if there is any contention occur in between the data, so-called it's a success probability. The success probability is that packet can be forwarded, that is measured as the probability of sum of burst loss ratio and link utilization. Okay, so for that, the time offset time is a major parameter. That offset time can be sufficient or may not be sufficient. So if offset time is more sufficient, what happens? The channel cannot be utilized properly. If offset time more sufficient means channel bandwidth cannot be utilized properly. If offset time is, we need to make it in a proper way, in such a way that we can go for channel utilizations. Next, we come for the in the in this technique there are some ma'am, please next slide. Okay, come to that result, adaptive burst assembly algorithm result. See that the based on the fuzzy inference system and based on the feedback adaptive burst assembly algorithm, we are getting some output. See that x-axis is the load, y-axis is the blocking probability. What is happening when we go for adaptive burst assembly algorithm system? We can go with blocking probability. The blocking probability can be minimized. The blue color showing the result, which is showing as per our method, adaptive burst assembly algorithm. One more, the violet color given fuzzy adaptive hybrid algorithm, fuzzy adaptive hybrid. So it is showing something more. It is not a adaptive burst assembly algorithm. Okay. So second one, delivery ratio. Delivery ratio also can be increased. Then burst delay can be minimized. Then burst drop also can be minimized when we go for ABAA. So this is one of the good idea when we take that fuzzy inference system adopt into the optical burst switching network. We can go for the betterment of bandwidth and utilization, channel utilization, and minimize the blocking probability and reducing the delay and all the way. The next challenges in OBS network, hybrid approach. Usually the hybrid, I have seen one research paper, hybrid approach 1 for reliable bufferless OBS network, as an enhanced multipath adaptive, like EMP ABAA. Previous case ABAA, now that same work have been extended into EMP, enhanced multipath adaptive. So let's go through that. Enhanced multipath adaptive means 1 plus n. N is nothing but n number of users can be done. Please, next, ma'am. The enhanced multipath adaptive burst assembly algorithm OBS network. Okay, here I have shown a diagram, user 1, user 2, user 3, even the destination also, user 4, user 5, user 6. So the way how the data, burst data have been transferred from user 1 to user 4 or user 2 to user 5 or user 4, whatever it is. So the technology is here. Ma'am, please next. See, the type of users, maybe premium users or regular users. Regular users in the sense we consider the low data rate. Premium user is nothing but high data rate. So the premium, see that when premium burst is received, that is a high data rate is received at the ingress node, it will send the same through its primary path towards destination and copy the same burst through protected path simultaneously. So what happens if more data rate is collected at the ingress node of the one of the WDM? So what is happening? The data is being transferred and keep it as a copy, not a buffer. Okay, keep it as a copy and make it as another route. If something happen in the primary path, it will go again. It will go through the secondary path. That is a so-called it's a premium user. Whereas regular user, like I told you, lower data rate. If regular users, one path is established, if the path is happening something, traffic or a contention occur, we can't go for, because in the regular users we don't have any reservation. We don't have any copy the data, buffer data. But regular users, once the data is being transmitted, if anything happens, that's it. There will be a losses. But when we go for premium users, nothing will happen. We will get a lot of advantages. No delay. The data, burst data can be transferred even if anything happen in between. That's what we are showing 1 plus n path formulation for premium users. We are concentrating only for the premium users. Suppose if a lower data rate is being reached the ingress node, that can be traveled through premium user. Suppose if any heavy data, burst data rate is reached at the ingress node, that can be make it as a copy and sending to the destination through the nodes. So again here, ma'am, please next slide. What is happening? Again, here also we can make use of fuzzy based new timer and a new length and load evaluations. The same process being happening here. So, but only the thing, the premium users. The premium users having path establishment. If one path is any problem occur failure, because already the copy of the burst data is available, that can be resent. Okay, in the another. If second wavelength is happening some problem, even we go for third one. If third is something happen, we can go for lambda 4 or lambda. Likewise, we can give the priority. That's what call it as a premium users. So in this regard, I have taken some output from the research paper. Ma'am, please next slide, ma'am. See here, enhanced multipath adaptive burst assembly algorithm delay is less and more reliable. Why? Because here something different. See that x-axis and x-axis is the number of node, y-axis is the delay. If number of node 20, 30, 40, 50, 60, 70, number of nodes crossed. But what about the delay? See the green color shows delay is very less. Okay, why? Because of the premium users. If we go for a regular users, definitely the delay will. Why? Because if the node getting a problem, if anything node failure, we can't send the data, we can't further proceed. So we don't have any alternate node. Whereas when we go for the premium users, we have so many alternate. That's why we have mentioned 1 plus n. Next, ma'am, please. Then delivery ratio. Next slide. Delivery ratio also getting good. Delivery ratio is very high in enhancement multipath adaptive burst assembly algorithm. See that green color showing number of node 20, 30. Number of node increasing, the delivery ratio also increases. Whereas the red color is the previous work, that is a old one. So what happened? The delivery ratio is coming down to 0.4 when we go for 100. At the same 100 node, the green color shows 0.8, that is a delivery ratio. It's obviously it is very high because we are using adaptive burst assembly algorithm at the same time premium users. Next one, that energy consumption. Next one, that energy consumption is also very minimum in the enhancement multipath, adaptive burst assembly algorithm. See that the green color shows. Okay, green color. When we go for the more number of nodes, it shows only it start from 5. Okay, energy delay consumption, whereas the red color is showing more or more than 6 point something. Okay, so when we go for that EMP, ABAA, even delivery ratio or delay or even maybe a power consumption, everything will be reliable and minimum, and we can go for this kind of. So in this way, what I'm the next point also packet drop, minimum packet drop. That also it is possible. See that green color shows the minimum. Based on that 50, 60, 70 number of nodes, the packet drop is also very less compared to the previous one, the red color. Okay, in that way, we can go for the optical burst switching network as I have started. With this, I wanted to conclude the research challenges in optical burst switching network. We have to go with different kind of technology, like what I'm saying, whether it may be a WDM or DWDM or ultra dense wavelength division multiplexing. The wavelength division multiplexing itself, we are getting tremendous, advantage variations. When we go for ultra dense wavelength division multiplexing, the same process, still we can reach the more number of data rate, and as well as we can further reduce the speed, delay, everything. So this is one of the advantage of burst switching network. And I request all the faculty, because nowadays I have seen that optical networks or optical communication side, the number of journal publication, even students, faculty members are not showing interest. So if we go with this, we can go for more research and easy to publish the paper in reputed journals, and it will be useful for our faculty as well as the student. One more thing, I would like to convey that it is related to networks. If you go with the optical fiber communication, the fiber is also acting as a very good sensor. Even fiber sensor technology, if you put the word in Google search, you may get a lot of research papers. So I request the students, you can go for small, the final year project or first year, second year, third year project work, go with a optical fiber sensor. Okay, the fiber itself acts as a sensor. I told you, fiber itself acts as an amplifier. So in these things, you can go with some small parameter comparison and the characteristics, what are the things are happening. If you do like that, we come to know the value and importance of optical fiber technology. So this is a future hereafter, because slowly complete electronics is replaced with photonics. So photons, light, energy is going to play, already started, but it's going to play a major role in future. Why? Because almost we are reaching 10 to the power 12 hertz, more than terahertz. So because the population, the data rate day by day increasing, more and more, getting everywhere traffic. In order to avoid, reduce the traffic, there is no other option. Everyone should go with a optical switching router networks. So without this, in future, there is no communication technologies. So with this, I just wanted to conclude all the informations. Please go with research on optical networks. I think everybody will be benefited. If you have any doubt or any clarification, please let me know. I'm there to help you. And if anything, please.
Participants, any questions? From Sangeeta ma'am, take care for 2 minutes. I will be back.
Sure, ma'am. Sure, ma'am. Sir, you were saying about the latency part of the fuzzy, which you are talking about. The fuzzy will be evaluating
Yes, madam.
the path. So, how it will take care about the latency outside the interconnection network? Sir?
Outside the,
interconnection network.
I'm not getting, but outside the interconnection network.
The fuzzy where you are applying
Yes.
to the interconnection network, right, sir?
Yes, madam.
So it is going to create some latency outside the interconnection network.
Okay. Okay.
So while calculating the latency of the network,
Okay.
how the outside latency because of this fuzzy is going to take care of.
Madam, what I'm trying to say, while going for assembling, assembling of burst data rate, no, we need to have that fuzzy inference system. In that, each and every node having, I told you, the feedback path. No, but in the feedback path itself, we can take only 3 parameters of the burst data. One is length, another one is time, another one is a load. Sometime we can predict it. Sometime more length data may reach. Sometime less data rate may reach. Sometime less length data rate. Sometime more time. Because randomly it may reach. All the thing will be segregated, assembled. Make it as a burst. Then that is why I have given like a membership method also in one of the slide, membership method. So low, medium, high. If madam able to follow, ma'am?
Yes, sir.
Yeah.
Membership value, if the data, time, low, medium, high, take 3-4 combinations. With the help of 3 combinations, we may predict anything. So what will be the next, whether it is going to be a traffic or a contention or any failure, that can be predicted well in advance. Based on the next node informations, the system will be that node will be sending the data, burst data. If something happen, it will be reroute without any delay. Reroute to the another node, then again, but each and every node having the feedback system with the help of a fuzzy inference call method. So by the way, we each and every node come to know what is going to be happen next. So likewise, predict each and every time, then without any delay, without any failure, the data further will be forwarded one to one, at last reaching the destinations. It is happening in the node, each and every node.
Okay. So the processing delay in the fuzzy is calculated separately, and then the network in the latency inside the network is calculated separately.
Yes, madam. It is calculations there, madam. Calculation is there, but I didn't take a full paper. Just I have taken a concept and output result only. It is there, madam, in the research paper. 2000, yeah.
Okay.
22, madam. The same AAB, adaptive burst assembly algorithm. If you put on a word, no, you will get the complete paper. There you can find that, the methodology.
Okay. Thank you.
Yes.
Is there any other question?
Sorry, sir. Like, can you tell me once again the paper name, if you possible?
Pardon, sir?
Can I get the paper name?
Adaptive burst assembly algorithm. You just type the name, sir. In the Google search, you will get the paper. And one more, I have shown the second, third challenges like EMP, enhancement multipath adaptive burst assembly algorithm. Both just to keep the title only. Because why I have chosen these 2 paper, adaptive burst assembly algorithm and going for enhancement multipath. So premium user and regular users, it will be so almost same, but slight modification. We can understand better.
Sir, in order to do this, project, we have to have the full conversional switch, right?
Yes,
that is the assumption we have to take it, right?
No need to have a full conversion, sir. That is the situations. Suppose the data is being transmitted from node 1 to node 2 in wavelength lambda 1. Node 2 to node 3, again lambda 1. Suppose if anything happened in lambda 1, we can reroute to lambda 2. So there we can say that fixed conversion. That is also possible. Like that, we need to keep algorithm in router. Router is nothing but here WDM, wavelength division multiplexing.
Yeah.
There itself we can keep algorithm, then it will switch over. If something happen, we can reroute lambda 2. So lambda 1 is a input, lambda 2 may be output.
Yes, sir. Yeah, I got the point actually. Even in addition to this, if someone is doing electro-optical network, the same technique can be implemented in that also. And then there is a variable data sets will also come into picture. So that can be taken into a next level. That is my opinion. Yeah.
Yes, sir. Yes, sir. Yes, sir. Sure. What you said, correct. Even OFDM, sir, can be incorporated into optical switching network because you know that OFDM technology. Okay, because in copper, in wireless communications, that bandwidth is may not support because lot of diversity. When we go for optical, we can make use of the channel bandwidth by using OFDM technology. That is also it is a part of switching network research area. And another thing that we need to make use of optical bandwidth, S band like 1460 to 1530 nanometer. So this is coming into picture in ultra dense wavelength division multiplexing. If you replace with WDM, we can go with the UDWDM, ultra dense wavelength division multiplex. I already mentioned there is a Opti system wave. There is a software. If you go, it is an open source available. Just download and install even in your laptop, and you go with. If you want, I can show the running statement, everything. I can teach that software, but you can establish that UDWDM. Again, you proceed with all the switching network with the same algorithm. Adaptive burst assembly and enhancement, multipath, all the way. Then what happened? One point of time we can reach that optimization technique. The channel, more than that we can't use. This is a maximum bandwidth limitation of even for optical fiber. That level we can reach.
Any other questions?
Good evening, Bharathi sir. This is Durga Prasad.
Sir, good evening.
Very good evening, sir. As I said earlier, it acts as a sensor.
Yes, sir.
Optical fiber acts as sensor. Is it acts as the partial sensor or full-fledged sensor? How can we justify it acts as sensor?
Yeah, it is a full-fledged sensor, sir. You just take an optical fiber. Okay, while you are constructing your home, you just keep your optical fiber where the beam joined, the floor and the beam joined. In the junction, you keep your optical fiber, and continuously you transmit the light from source to load, like LED to detector. The light signal will be continuously traveling. If something damage occur in between the beam and flooring, beam and what you call the roof, flooring, the beam and the roof. Okay.
Okay, sir.
What happens if something happen due to the pressure, the fiber shape may change from circular to some other form, due to which the light signal also may change. You may get loss at the end. So by calculating continuously what is output, say for example, 1 voltage transmitted signal, the same 1 voltage you have to receive. If something happening, maybe 0.8 or 0.7 or 0.5, something happen in the fiber. Okay, that's what I told you. The cylindrical shape change it to some other elliptical shape because of the pressure on the roof and the beam. So what happened? The fiber is getting deviation getting the different output. By the way, you can calculate, okay, something happened in the building construction. So now what happened? We are coming to know that the building problem. So it acts as a sensor. At the same time, the fiber can be established in, the flyover bridges. Then from there also you come to know the age of the flyover or age of the building and all the way. So 100% the fiber itself acts as a full-fledged sensor.
Yeah, that's okay, sir. I will try. Thank you so
Yes.
much, sir.
Yeah, definitely. And another thing, till now we have discussed about optical linear system only. When we go for a non-linear system, then I think most of the professors know that the fiber act with a non-linear, the solitons pulse come into system. So far it is a solitons in optical communication system, solitons in optical network. That is completely different chapter. So far, whatever we discussed, everything will be in everything is in linear system.
Yes, sir. Yes, now.
Once if you go for non-linear, we can reach our solitons. The soliton is nothing but theoretically people are defining the term. The soliton pulse can be transmitted up to 180 million kilometers without any loss. This is a statement of soliton pulse. Once if we generate the soliton pulse, it can carry the message up to 180 million kilometers without any loss.
Yes, sir. Yes, sir. Yes, sir. I think we have come to an end of the session. And now I invite Dr. Sangeeta, Professor, BIT Chennai, to propose vote of thanks. Please, ma'am.
Yes, ma'am. Thanks for organizing this session. And I want to thank Professor Bharathi, sir, for participating in the last minute announcement. So he patiently explained each and everything and explained about how crucial the design of switches and what are the different types of switching which is available. And he also gave the thought for the researchers, upcoming researchers, to know more about the research in the area of optical networks, because this is an upcoming area, but people are not showing much interest on optical networks, which is very much required. So we would like to thank the speaker for exploring more concepts based on optical networks. And all these new concepts are really useful to the new researchers. I hope it will be in future also. We are going to organize many such events. So participants, please participate in the future events as well. So I would like to thank IEEE Madras section for giving the opportunity. Thank you so much for the wonderful meeting.
Thank you, ma'am.
That is, we have to thank Ratnavel sir also.
Madam,
for
1 minute.
arranging
Just
such a one. Yes, sir. You few words from Ratnavel sir.
Sir,
okay.
good evening, sir. This is Bharathi.
Good evening. Good evening. So really, I thank to Mr. Professor and Dr. Bharathi for accepting our invitation on behalf of IEEE Madras section and IEEE student branch in a short notice. Really, it's nice. And your research in this optical area networks is, I think it is an overwhelming. Hope that you will be still in that maybe your experience and your knowledge may be shared with sometime in future some hands-on workshop or hands-on training. Maybe we'll discuss with our team and let you know it. Okay, it's good. The session was very good and the explanation was very nice. All the best for all the participants and organizers. Thank you.
Thank you, sir. Thank you.
If possible,
I request Arun sir to share the e-memento, or shall I, sir? Arun sir? Yes.
have a
1
group
second.
photo as well.
Yeah, e-memento. Yes.
Yeah, we will have first a group photo, ma'am. Then we will go for e-memento.
Yes.
Meanwhile, I'll take it.
On the videos participants.
I request
1, 2, 3. Yes, sir.
1 second, ma'am. I'm sharing it. Second, ma'am. Sorry.
I will, shall I try, sir?
Yeah, ma'am. You share it, ma'am, please.
Okay, 1 minute. Oh, the thing is stop share. One sec. Sir, I have
Ma'am,
started.
it's
Sir, myself also something happened. Yeah.
ma'am, my screen visible arka, ma'am.
Yes, sir. Yes, sir. Yes, sir.
Sir, please do accept the C memento on behalf of IEEE Madras section.
Sure, sir. Thank you, sir. Very good.
Yes, sir. Thank you, sir. Thank you very much for accepting our invitation. Thank you.
Thank you, sir. Thank you, ma'am.
I thank all the exam members of Madras section for providing support to organize this kind of event. Thank you all. Thank you, participants. We'll meet with another event.
Thank you, ma'am. Thank you, ma'am.
Kindly fill up the feedback form. I hope you all completed this. Fill up the feedback form. You will be receiving the certificate.
Thank you, madam. Thank you, sir.
Yes, we'll find it. I will
We-
end the
We can
meeting.
end the meeting in a couple of minutes, ma'am.
Yes.
Sir, can I leave, sir?
Yes, sir.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Thank you, sir. Arun, sir, thank you.
Thank you, sir.